Hi everyone, this is Patrick Palucci with Slooh Space Camera. It is about 4:05 here on Tuesday, July 2nd. Sorry for the late start. We are working through some issues on the back end here, but we've got our show going. And fortunately enough, I was able to round up Bob Berman, longtime Slooh friend. Bob, how are you doing today?
Excellent. Thank you, Pat. Great being here, and it's very exciting.
Great. Well, what we're going to be doing, guys, is we're going to be looking at a supernova in NGC 4414 today. And Paul Cox is going to be reporting in live from the Canary Islands in a second here as we get set up. But what I'd wanted to do first is kind of talk to you guys what we're going to be doing and where these feeds are coming. Now, these live shots are from our observatory in the Canary Islands. Now, some of you might know where that is, but for those of you who don't, that's off the west coast of Africa, and I'm going to show you a little quick graphic that's going to lead us there. Um, this is a world-class observatory site that we've been at for many, many years. Now, this is a professional observatory area, and these feeds will be coming in live from that of the actual supernova. So here is some quick images of it, so you get a kind of an idea of the facilities there. These are pretty substantial facilities, and that's where our facilities are located as well. So now, Bob, one thing I'm going to be doing here as we get started is I want you to talk about what a supernova is, if you don't mind. I'm going to be pulling up some before images of the galaxy that were taken actually by a Slooh member on June 7th. Now, this galaxy, before Bob gets started, I'm going to pull it up right now so you guys can see it really quick. This galaxy is about 62 million light years away, so it's pretty far away for us to capture. But I want to give you guys a close-up view of it really quick so you can see what it was. This was on June 7th, about 20 hours before the supernova occurred. Now that's pretty fascinating that a Slooh member actually captured this right before. And the name of the member is Randall Astafulf. I believe that's how you pronounce his last name. But Bob, maybe you could tell us a little bit more about what supernovas are.
Oh, yeah. And this is very exciting, too, to be able to capture a pre-supernova image like this, as the Slooh member did using the Slooh telescopes, was just fantastic. This is the galaxy before the supernova went off in the northeastern side of it. And when a explosion of that type takes place, it really shows up. Even though this galaxy, being 62 million light years away, is so far away, we cannot see individual stars. In fact, nobody can, regardless of the size of the telescope. But using now the latest images from Slooh, compare the picture we're looking at now, the one that was taken a month ago, just before it went off on June 7th, to a current image. This just came in from Slooh now, and you can clearly see that supernova that went off in the spiral arms of the galaxy. It's not surprising that the galaxy's spiral arms were the home to the supernova, because that's often where the most massive, youngest, most unstable stars can live. Now, there are two types of supernovae, essentially type 1 and type 2. This was probably a type 1A supernova, and that's when two stars either coalesce. There's even some evidence that they may coalesce, or material from one star falls onto the other. Now, normally you get a white dwarf star being the recipient star from the material that's outgassing from the other, and at a certain point, a critical mass is reached and the whole thing blows up. The other type of supernova, type 2 supernova, involves a single star reaching its old age where it no longer can support itself, and the whole star collapses on itself. Either way, you're in what's happening is the total destruction of the star. Some of the material rushes outward, including a production of what will eventually be cosmic rays that arrive here and can be harmful to astronauts outside of Earth's protective magnetosphere and outside of our atmosphere, and may present a big hazard to future astronauts going to Mars or even to the Moon. And plus a stream of neutrinos which don't harm us, and probably the obliteration of any life that happened to be on any planets around this unfortunate star system. So it's very exciting to see this happen. Of course, spiral galaxies are beautiful. More so than the blobby-looking, irregular, elliptical galaxies or the spherical-looking galaxies like M87. Now, these are gorgeous galaxies, and this one, at a typical distance to the heart of the Virgo cluster of galaxies, this galaxy, NGC 4414, uh, shows some of the features that we love to see, the multiple spiral arms. This is not a classic grand design galaxy. This is a more has more chaotic arms in it, and it is in one of these spiral arms that you can see there's that supernova carrying the brilliance of millions of suns, and they're fascinating to study because to a large extent the brightness of a supernova is the same no matter what kind of galaxy it's in. The same type of supernova, type 1a here, will have the same brightness as any other. Recently, we found that there are little variations on this, and that has to be figured in, but they serve as beautiful ways to determine distance to galaxies, because there's no rulers that are going to stretch out from here to this galaxy 62 million light years away, but what we can do is measure the peak brightness of this supernova, compare it to the peak brightness of other supernovae that we've seen in the past, which tend to have the same or more or less the same peak brightness, and then by that method find the distance to the galaxy more accurately than we've ever been able to do in the past.
Um, what I'm going to do now is I'm actually going to show in some images that were taken by Slooh members recently. And what Slooh members get to do is they've been tracking this stuff in real time, and what we're seeing on the live images is that's what you'd see, give or take the quality level depending on what the object is, but that's a real-time view. Now, some members can go to the FITS data and build and stack and do all these things to kind of clean up the images. And what we're seeing now is from Slooh member Dave Larkin. He did this recently, and he's pointing directly to where that supernova is. So if I go back to the last shot that we just had, we can kind of get an idea exactly where. I'm going to bring that back in here. You can see exactly where it's at using where Dave Larkin pointed out. Now, this particular. Now, Bob, did you mention this? There was a difference. They mentioned it's a Type 2 supernova. Can you tell us what that means, or do you know what that means off the top of your head?
Yes, yes. Type 2 supernova, even though it has the number 2 in it, it really means that a single star was involved. This is a massive star reaching its old age, which paradoxically happens kind of soon in very massive stars because they go through their life cycles faster than a normal star or the way our sun would. And a Type 2 supernova means that a second object was not necessary. You get a single star that can no longer support its weight. Now, the sun, let's take the sun as an example, because it can never form a supernova. It's just not heavy enough. A star of one solar mass, like the sun, weighing the same as 333,000 Earths, sounds like a lot, and it has a lot of gravity on the sun. So, of course, it wants to collapse. Gases are compressible. The sun would love to be smaller than it is. It would love to collapse on itself. It can't. And the reason it can't is because there's an outward pushing pressure from the core, thanks to its nuclear furnace, the fusion reactor in the central 12 or 13. But in this galaxy that we're seeing now, that the Slooh space camera is imaging, what happened is that the star used up its core material, its hydrogen, and in its old age it could no longer supply the outward pushing pressure that counteracted the gravitational urge to collapse. And when that happened, the star started to collapse. The collapse translates into more and more heat in the center, and in a split second, the thing becomes runaway. And instead of normal, placid fusion process of hydrogen to helium, or helium getting translated into oxygen and carbon, instantly the pressures were high enough for different types of fusion to occur. And when that happens, bam, this type of supernova, which is a single star, again, exploding. There are two main types of supernovae. as I said, type 1 and type 2. And in this particular case, you have this runaway explosion. You don't need any help from anything else, but by itself, it has produced this explosion. So it's wonderful to be able to watch this right before our eyes. How common is it? One of the estimates is that in each galaxy in the universe, and there are 200 billion known galaxies, in each galaxy, a supernova happens about once a century. We haven't seen any in our own Milky Way galaxy since the first years of the 17th century. In the early 1600s was the last time we had a supernova here. So they're not that common. But when we look to other galaxies, again, if one goes off per century, and we have so many galaxies within view, and the Slooh members are watching these galaxies, and so are astronomers all around the world. It won't take too long before some galaxy in the universe has a supernova exploding. And in this case, this is only 62 million light years away, so we're seeing it very clearly.
Yeah, so I'm actually going to go point to it for those of you who came in later. Where my cursor is, that's the supernova that we're seeing right now, and that's the images. These are live from the Canary Islands observatory. This is for those of you who don't know where that is. It's off the coast of West Africa. We're about 8,000 feet up in a world-class observatory site, and it is pretty amazing, Bob, that this image is actually coming in live to us 62 million light years away. So if I'm right, does that mean that this happened 62 million light years ago, or how?
62
Yeah,
million years ago, yes. 62 million years ago, which is just around the time the last dinosaurs walked on the planet Earth, just before, interestingly enough, we now believe a great impact event that created the Chicxulub crater, part of it buried under the sea off the Yucatan coast at the boundary between the Cretaceous and Tertiary periods of Earth. 65 million years ago, the dinosaurs were extinct on Earth. A mere 3 million years later, this explosion happened in the galaxy NGC 4414, and the light from this supernova has been traveling all this time, since about the time the dinosaurs went extinct, to us, and has just now arrived, or arrived here on June 7th or so. We're talking about 3 weeks ago. Bam! And we received this influx of material. And it is material. It's not just light. It's not just images. We also get a swarm of neutrinos and subatomic particles that are traveling at almost the speed of light that have also been blasted outward. Again, here is the pre-supernova image, also taken by Slooh. This is what the galaxy looked like before that supernova went off. And then look at the northeast side of the galaxy. Look at the outer spiral arm of the galaxy. There's no trace of any other stars there happening. And now compare that with a Slooh image today, right now, of this galaxy. That's what we're looking at now. And there's no doubt about it. You can see how suddenly this section of the galaxy, the northeastern side, is being lit up
yeah,
by this titanic
yeah.
explosion.
It's definitely very bright and noticeable, and a lot of amateurs discover supernova, Bob, or is it who usually finds them?
Well, it can be surveys. There's automated equipment looking for it. Some amateurs find them. Of course, there's always a rush to do it. It's a little less compelling, Pat, than the search for comets, because unfortunately, the naming system, the nomenclature of supernovas, is that they simply get a year designation followed by letters. For example, this was 2013 DF, according to what order the supernova was found in. Whereas if you discover a comet, well, then it has your name attached to it. So there's more, just I guess, for the ego or for the glory, it's more compelling to be the first to find a comet than a supernova. Nonetheless, hey, I wouldn't mind telling my friends I found this supernova. Unfortunately, the public is kind of oblivious about astronomy, so if they say a supernova, where? Well, it's in galaxy NGC 4414. That'll put people to sleep. But
Yeah, exactly. Well, we're trying to enlighten the general public about what these things are and how far away they are. One quick note,
yes,
guys. For those you don't know, we do have an iPad app that we relaunched. and I'm going to throw up some shots of it really quick. It's a free download, and you have the opportunity to control these very same robotic space cameras, we call them, on top of the Mount Tidy in Canary Islands. So go ahead and download it. If you do command a mission, just hit that start mission button to any object in the sky chart, and you're actually, for a fee, can book a mission and image the night sky. It's a really cool app. It also gives you access to all our free programming, and generally speaking, it's been well received, and it's starting to, I think, catch on a little bit. So if you do have an iPad app, please go ahead and try it out. It also helps support all the live programming we do on Slooh. So when you do book a mission to something in on the app, you're actually supporting the live programming we produce for the general public. And there's a lot of cool objects out there. We're actually highlighting this week and next galaxies under very low light conditions, moonlight conditions. So it's really a nice time to go ahead and command missions to some of those galaxies we have listed under top missions. Bob, we have about 5 minutes left in this broadcast, and I'm going to go ahead and pull up the live feed here in a second. What else could you tell us about a supernova? Because I know I was looking at our own galaxy, the Milky Way galaxy, and it was saying that the last supernova to occur was about 400 years ago, and that seemed like it was kind of long. What could you tell us about our own galaxy as far as supernova are concerned?
Well, it was interesting. We have had supernovae in the first years of the 1600s, in the final years of the 1500s, with names like Tycho star and Kepler's star, because these were the astronomers that were around then. We had a great supernova that went off in the year 1054 that created the Crab Nebula. We had one in the year 1008 in our galaxy. And now we've had this long period, this 400-year hiatus, where we've not had a single supernova go off in our galaxy. So we're overdue for one. In fact, even in our companion galaxy, the Large Magellan Clouds, we had a supernova go off in the late 1980s, and that was fun to watch. I led a group of people down to near the equator to see it at that time, and that was the closest supernova in anyone's lifetime in 400 years. So generally, Pat, we've got to look to other galaxies in order to see them, and we don't want to be too close to a supernova, because if our sun, of course, could become a supernova, which it cannot, thankfully, it would destroy all life on Earth. We think that the nearest star that that is likely to have a supernova is Betelgeuse, and here we're talking about something in the area of 600 light years away. Betelgeuse has recently been pushed back a little further. We used to think it was about 450 light years away. Now we latest data indicates it's a little further than that. Betelgeuse is kind of on the brink, and there are some other stars. Eta Carinae is really on the brink. But the nearest massive star, and only massive stars can blow up like this, the nearest massive star is the dog star, Sirius. It has the weight of 2.4 suns, and it's only 8.5 light years away. But we think 2.5 suns of weight is not enough for it to blow off into a supernova. It really needs more than that. And so we're safe. We're not going to get one in our neighborhood. It's almost a blues song. Nobody knows the troubles I've known. It's just this is back here. This is an unfortunate turn of events for any planet system out there in this galaxy. We're safe from it.
Excellent. Well, that's good to hear. So now our own sun, you had mentioned, won't go supernova, you said, but what will happen to our sun for those who are interested to know?
A much more placid, but still fascinating fate, as our sun eventually first swells up into a red giant star that may even extend out to the orbit of Earth. This will be in about 5 billion years. Then shrinks down and puffs out some of its gas into a beautiful aquamarine and greenish looking um, planetary nebula. I know one of the things the Slooh space camera members love to look at are some of the other old stars that are very much like the sun that have already reached the stage where you can see bubbles of material, bubbles or barrels and other interesting shapes. And these don't last very long. They last 30,000, 40,000, 50,000 years at most, and then they much more of a wimpy, if briefly lovely, fate some 5 or 6 billion years from
Well,
now.
I look forward to covering that one live on Slooh. That's going to be a really cool event.
Yes, yes, but and meantime we'll watch other suns as they go through their old age and death contortions, because some of them are quite lovely. Also, kind of poetic and lovely, Pat, is that a supernova such as the one we're seeing here throws out such heat that it creates new elements that were never created either in the Big Bang or in the nuclear furnaces of stars. So things like the iodine in our thyroid glands and other more massive elements, anything that's heavier than iron, is produced in a supernova explosion like the one we're seeing right now here at Slooh. And those elements get sprayed into space and eventually get connected with and picked up and merged with nebulae of mostly boring hydrogen gas, and the marriage of those two produces planets and new star systems with more interesting components. And that's what happened here in our own solar system. We have material from a supernova just like this in our bodies, in our planet, and obviously necessary for life. So this is not just death and destruction that we're looking at. This is also the groundwork for the next generation of life and new
Yeah,
planets.
so what I'm doing now is I'm showing Slooh members when they go in and image the night sky, they get the live version of it, which is actually pretty fantastic. But they also have the ability, if they'd like, to go do some what we call post processing to the images, usually through FITS, accessing FITS data and such. And I'm showing an example from Slooh member Dave Larkin, who did one of this, and he's really zoomed in a little bit and got a little clarity on the galaxy itself, but also pointing to exactly where the supernova has taken place. And so you kind of, members definitely have more control than the app guy. The app guy is more casual user who wants to image the sky and not deal with all the challenges of with astronomy. The member guy is more interested in, probably owns a telescope and uses it frequently. So we do have two different types of ways to do Slooh. But either way, I highly recommend the iPad app, guys. It's a unique way to image the sky, but you also get access to all of our programming right from the app itself. So it's a good product in that regards, and it's free download. But if you do want to command a mission on one of our robotic space cameras located on the Canary Islands or elsewhere, you will have to pay a fee. They generally run about $1.99 a mission for the top missions, and then they move on up from there. But we try to keep it affordable, so for the masses, so they could do it as well. So definitely check it out. It's an iPad app only, and we hope to release an iPhone version and Android soon as well. So, Bob, this pretty much is going to end our broadcast for today. I appreciate you jumping on last minute. We actually were set up for Paul Cox in the Canary Islands, but he had a tech issue with his audio or something that we could not figure out. And Bob, actually, I didn't even know if Bob was home. So,
Yeah,
uh,
yeah. I just got back from
yeah.
Hawaii, just actually, yeah, just a few hours ago. So I'm glad to have been here because this is a very exciting event
Yeah,
here at
so no,
Slooh.
I appreciate Bob for you coming on last second like this and helping us out. And Paul has been doing a lot of work out there on the observatories, which we hope to be wrapped up soon. And sorry, Paul, you couldn't join us today, but we'll get you on perhaps maybe later this week after the 4th of July or such to talk about what's going on out there in the Canary Islands. All right, guys. Well, Bob, again, thank you very much for joining us today. For Sleuth Space Camera, this is Patrick Palucci. Have a great 4th of July for all of you in the United States. It's always a good time of the year, at least in the West Coast. I don't know about you, Bob. Is it pretty humid out there right now?
Oh yeah, it's very humid, and you know what? Fourth of July, this galaxy has helped us celebrate it, hasn't it? With the fireworks of its own.
Exactly, for the Big Bang. So, guys, all right, well, have a good one. And if you want to keep updated on our future events, you can always go to the home page. You can use your app. If you do download the app, make sure you've got your notifications on. We do send out notifications when our next events goes live. Or you can follow us on Twitter or Facebook or one of those things, and we usually make posts there as well. All right, well, have a good one, and we'll talk to you later.
Okay, thank you, Pat.